Hey Human Phys class, this is Mr. Yago. This is your first video in Chapter 9, Circulatory System. And these videos are going to serve as our discussion / note days as my schedule will slowly change during golf season. It's a means of making sure that we are getting through the curriculum and that you are getting to hear my pretty voice when I'm not here. So, with that said, this is stuff that I do want you to continue to take notes on. These are notes that I will check at the end of each unit and will definitely serve as a good portion of your assessments. So these will be section by section. 9.1 is going to be heart's role in the cardiovascular system. Up to this point, we've talked a lot about blood. Now we're going to talk about some of the anatomical and physiological processes that are going on in the circulatory system. So here we go. So by the end of this unit, the major things that I want you to learn and understand are the difference between the pulmonary and the systemic circuits. In addition to that, we're going to look at what the difference is between an artery, a vein, as well as a capillary. And we're going to understand how each circuit, both the pulmonary and systemic, works with the heart as well as its chambers. And that's going to be a big portion of this unit as well, is looking at the heart, how it works, how it pumps, what the lub dub is, and all that good stuff. And we're also going to look today at identifying the heart's anatomical location in the body. So first thing I'm going to have you guys do is get some vocabulary development down. We haven't done that in a while. Big terms we're going to use a lot. I hope as you're going through here you notice we have a few from previous units, but should be a lot of new stuff. So I'm hoping right now that you just hit pause and jot these words down, and we'll get started on the next slide when you're done. Alright, so let's get started here. So one of the major things that we're going to discuss is, what's the heart's job? What's its purpose? What does it do on a daily basis? As you can see here, this is a sheep heart. So you're going to get very, very familiar with these in the next couple weeks as we do a dissection. But the heart beats approximately 100,000 times a day. Now, a lot of people think, okay, what about people that exercise a lot? That's kind of an interesting fact because yes, it might exercise more it might beat more when you're exercising, but usually people who tend to be very healthy have actually low resting heart rates, which is a resting heart rate when you sleep, when you're not doing much. My resting heart rate's usually around 55 or 60, which is pretty much a beat per minute, and that's a little bit below average. Not saying I'm healthy by any means, but I remember a couple of my friends in high school used to have resting heart rates around 40. Usually if you're somewhere around 60 to 80, you're perfect. And this will pump roughly 8,000 liters of blood, which is enough to fill 40 55-gallon drums. That's a lot. As we talked about in the previous unit, females on average have 4 to 5 liters in their system, and males have about 5 to 6. So you can imagine doing the math. You take that 8,000 divided by that 5.5 to 6, 4 to 5. It gives you just how many times your body's circulating all your blood every day. Despite its heavy workload, though, it is literally the size of a clenched fist, just to give you some perspective. So if you clench your fist, that's about the size of your heart. So let's take a look at these circuits. As you can see in this picture to the right, I know you're writing stuff down right now, but blood basically flows through a network of vessels, all right, and that'll extend from the heart through peripheral tissue. So we're talking about up to the head, to the lungs, to the arms, down to the legs, into their internal organs. But at least this picture gives you an idea of what's going on. And I hope you're realizing that we have areas of blue, we have areas of red, we have areas of kind of white. And hopefully you're noticing that these blood vessels are subdivided into the pulmonary circuit, which basically runs out of the heart to the lungs and back, and also a systemic circuit, which is going to carry blood to and from the rest of the body, so all the way down to the legs, up to the head, out to the arms. Now, why do we have these two separate circuits? Well, the major thing is that blood transports oxygen. We know that. So we need to be able to have a circuit that runs from the lungs and back. And we also need to be able to take that fresh oxygenated blood, which I'm going to point is coming right here. Okay, this would actually be your left atrium. Because if you take a look here, both this red pulmonary vein and this red pulmonary vein are going to be bringing oxygenated blood. So in this case, this picture of red is oxygenated blood, and that's going to be pumped systemically throughout the body, up to the head, into the internal organs, and into the legs. Notice that this is the aorta, a very commonly known artery called Big Red. Now, each circuit begins and ends in the heart. So take a look again. It begins and ends in the heart. So you could say right here in the left atrium, it begins here, pumps out, ends in the heart. This right here pumps out of the atrium, comes all the way back around into the heart. So these two circuits are working together constantly. So now that we understand that we have these circuits, let's take a quick moment to look at the difference between arteries, veins, and capillaries. Now your first assignment 9.1, which you'll be working on tomorrow, is mainly going to deal with differentiating between arteries, veins, and capillaries. So we'll go into a little bit more depth. But today, here's what I want you guys to know. One, refer back to some of these terms. Efferent, meaning carrying away from the heart. So arteries always carry blood away from the heart. Veins are afferent vessels, so they're always carrying blood toward the heart. And last but not least, in the middle here, we have capillaries. These are super small, thin-walled vessels between the smallest arteries and smallest veins. I'm not doing this full justice. In between arteries and capillaries, we have something called arterioles. That would be the smallest arteries, and we have venules, which are the smallest veins. Why do we have it that way? Well, this is where we're going to interact with our tissues, and because they're so thin, it permits it to exchange nutrients, dissolve gases, and then waste products between these surrounding tissues. So this is a vital system. Capillaries are found in a majority of your vascular tissues, because that means that those are tissues that have blood in them. For example, you'd have capillaries in your dermis, but you would not have capillaries in your epidermis, which we know from our integumentary system unit that is a non-vascular area. All right, so we're going to do a quick, very brief. We're going to go into much more detail when we talk about the heart, but the heart contains 4 muscular chambers, okay? 2 are associated with each circuit, okay? So we're going to start out right atrium. You got to get in the map here. We got to think anatomical. This is actually your right atrium. Okay, so although we're looking at this picture, you know, as blood is coming up from the body and also coming down from the head and the arms, it's going to enter right here. This is called the superior vena cava into the right atrium. So that's where we receive blood from the systemic circuit. Once that contracts, it's going to empty through a valve here into the right ventricle. And that is going to take our blood. If hopefully you're thinking right now, this is a pulmonary artery. It's going to take blood, 1, artery away from the heart, as you see here, and 2, it's pulmonary. That actually means lungs. All right, so that's what the right ventricle does. Notice that the right ventricles are also bigger than the right atrium. So that might be something to note, that the right ventricles are bigger than the atrium. And you'll also notice that one ventricle is a little bit bigger than the other. Not so much in this picture, but definitely in the future. Now, left atrium is right here. So when blood comes back, the pulmonary vein from the lungs, that's where it's going to enter, and that's going to collect blood from our pulmonary circuit and then empty into the left ventricle. Now, leaving the left ventricle, we have oxygenated blood that is going to pump into the systemic circuit. So the aorta is going to branch off up to the head, up to the arms, all the way down. There's a descending part right here that would come all the way down to the body. So again, we'll go into this in much more detail, but I just want you to get an idea of what are some of the major parts of the heart that we're going to be working with. All right, so when the heart beats, 2 atria contract together first, okay? That's going to be your lub sound. All right, when we hear the heart, we go lub dub, dump dump, dump dump. So that first dump, or what we call the lub, is the two atria contracting. Remember, the atria are the two smaller chambers up here. So essentially all they're doing is they're taking blood and squeezing it into the ventricles, which are much bigger cavities. Then the ventricles contract, and that's the dub. So boom, 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 boom. That boom is going to be when we take blood and either push it out into the lungs or push it out into the body. So these two ventricles contract at the same time and eject equal volumes of blood. Okay, equal volumes of blood. This gives you a little bit of what we would consider the circuit or cardiac cycle. We have what we call our atrial systole, okay, and we also have a ventricle systole, and then we have a ventricle diastole. Now, if you know anything about blood pressure, we have two numbers. Good healthy blood pressure is 120/80. That is the systolic over the diastolic. Hopefully some of you have heard that before. So the systolic over diastolic. So we take your higher pressure should be your atrial and ventricle systole, and then your lower pressure should be your diastole. All right, last but not least, our last slide today is going to be dealing with anatomically where's the heart located. I want you to notice this picture here. Love this picture. This is straight out of Grey's Anatomy, not the TV show. These are some of the very first drawings, which I just find fascinating. So if you ever want to take a look, Grey's Anatomy is always on my desk. I have, I think, 1 or 2 extra copies. I know I have one at home. But if you ever want to just page through it, there are some excellent images like this, and that's the very first images that we see. Make an observation. What do you notice about the heart? What I'm looking at is I'm definitely seeing that it is kind of tilted to its side. It's not directly up and down as most people think. It's actually tilted a little bit to our anatomical right. But the heart lies in the anterior chest wall. So if we're looking at the chest, it's in the front of it. And it's directly behind the sternum. So remember, the sternum is a bone right in the front of your chest, and it sits directly behind that. It is enclosed by the mediastinum. Hopefully remember that. That's a cavity. Big cavity. It sits right here. Goes up front to the, I'm not thinking, a thyroid gland. There we go. And all the way down around the heart, which is the connective tissue mass between the two pleural cavities. So we have our pleural cavities around our lungs. Hopefully remember that. And then our mediastinum is right there. There's also another area that we're going to talk about, and that's what encases the actual heart. It also contains the largest arteries and veins in the body. So if we branch over here, this red one, big red, is actually our aorta. Okay, and this big blue one here is the superior vena cava. I also want you to note that we also have blood vessels running over the heart. These are the coronaries. So you got to understand that the heart is a muscle. It's alive. So every time it beats, it's not only feeding oxygenated blood to your tissues, it's also feeding it to itself. Okay? So I hope you hit on today's learning objectives, have an understanding of the major parts of the heart, you know, how blood moves through, the difference between arteries, veins, and capillaries, and a really big understanding of, you know, what exactly is the heart's role. A lot of blood to be pumping, and as we move forward, we're going to find out where it's going to and how it gets to the places it needs to get to. That's all I got for today. Hopefully this concludes all the note-taking for today, and then tomorrow you'll be going into assignment 9.1, which is going to be looking more into arteries, veins, and arterioles. Make sure you took good notes. Remember, I'm checking them, and then take a look at your framework and see what we have for the rest of the week. All right, that's all I got. Yago, out.